this is Shelby with the Rogers Public Library. So, continuing from last week, I'm going to talk again about kind of spooky Halloween science. This week, we're going to be talking about fluorescence. Now, you probably know what fluorescence is, although you might not have heard it called that before. So, what it is when you shine a black light on something and it has a little tiny bit of a glow. You can't see this really well right now because the light's on, but we're going to turn them off in a little bit and you'll see that a lot better. But fluorescent things, they have kind of this characteristic eerie look to them, right? They almost look, brighter than everything else. Like you have this really bright orange paint and you have a really bright yellow highlighter. So the way that fluorescence works has everything to do with atoms and like the atomic structure and stuff. So you remember about atoms, you know that in the middle there's something called the nucleus. And then there's an electron that orbits around the nucleus. So there are different orbits that an electron can have. And when it's really close to the nucleus, we say that's the ground state, right? That's the lowest amount of energy that the electron can have. But sometimes if the electron gets more energy, it can happen in a variety of ways. We say that it's excited and it moves out further away from the nucleus. But it doesn't stay there forever, right? Eventually, it's going to lose that energy and it's going to return to its lower state. And when this happens, it releases a photon, right? So photons, that is, it's the carrier of light. We talked about this as well. It's like a really, really tiny packet of light energy or electromagnetic energy that light is made out of, right? So, and then this photon, it flies out from the atom and it just goes off into space, right? And eventually the photon is going to hit another atom. And a couple of things can happen, right? It can just go past the atom and not interact with it at all. Or it can get reflected off, right? So you have a mirror in your house, then when you see your reflection in the mirror, that's because the mirror is bouncing photons back at you, right? But something else that can happen is the atom is absorbing the photon. And when that happens, well, a photon is a form of energy. So you have the electron move up from its ground state to the excited state, and then it falls back down and it releases a second photon, right? So we can kind of think of these photons like basketballs, right? So when you bounce a basketball on the ground, it bounces up really high. And then every time it falls back down, it bounces a little bit lower and lower until it stops. So when a photon hits an atom, and that atom releases a photon, the second photon it doesn't have as much energy, right? So we say that it has a longer wavelength, right? This is the light spectrum or the electromagnetic spectrum. So the way black lights work is they release a little bit of purple glow, right? We see a little purple bluish light, but they also release invisible light that we call ultraviolet. Now, ultraviolet light, it's actually the part of sunlight that gives you sunburns. So you want to be a little bit careful when you mess with it because it can hurt your skin and it can hurt your eyes. But this and the other black light they were using today, they don't release a lot of ultraviolet light. So they're pretty safe, but you still want to be careful if you play with them. So it's actually the ultraviolet light from the black light that makes a difference, right? So when the ultraviolet light hits a fluorescent object, and these are called fluorophores sometimes, but it's just easier to call them fluorescent. So when it hits a fluorescent object, that ultraviolet radiation gets released, and then visible light with longer wavelengths, is emitted. And so that's why fluorescent things seem to glow, because they're absorbing light that we can't see and releasing light that we can see, right? And so things that we see, light that we can see is a lot brighter than light we can't see, right? It just makes sense. I guess the question that you're wondering about now is, how are black lights made? Well, one way has to do with something called fluorescent bulbs. So if you ever go into a store and you see really big, long lights on the ceiling, the really long tubes, those are fluorescent bulbs. And there are also some that you might have in your house. They're the curly light bulbs. So those bulbs on the inside, they're coated with something called white phosphor. And this white phosphor is like a powder that glows white when it gets hit by ultraviolet light. And then and the actual inside of the bulb is mercury vapor. So in the mercury vapor, when you run an electric current through it, it releases ultraviolet light. And then that light hits the white phosphor, and the white phosphor glows white. And a black light is basically a fluorescent bulb that doesn't have a white coating. It might actually have a purple coating like this, right? So it's got purple glass. I think it might be Wood's glass, but it doesn't really make a difference if it is or not. It's purple, and that means that it blocks out a lot of the visible light, and it lets the ultraviolet light and a teeny tiny visible light through. But this one is not fluorescent, right? We can see it's not curly. It actually has LEDs in there, but it works the same way. It's just a little bit safer because it doesn't have mercury in it, and mercury is poisonous, right? You don't have to actually buy a bulb to play with fluorescent stuff. So this, it's another LED fixture. So it has white LEDs in it, but I put some tape over the lights, and I colored it purple, and then another piece of tape that was blue, and I just layered those until it got this nice bluish color. It looks a little bit different from this, but it works relatively well. Not as well as this, but it works well enough that you can see some pretty cool glow stuff. So now we're gonna turn off the lights. I'm gonna talk to you a little bit about the cool types of artwork that you can make with using fluorescent materials, and also I'm going to show you guys an experiment. Okay, so now that we have the lights off and we have our black light on, you can kind of see the fluorescent glow a little bit better. So for instance, these are the monster tissue boxes I showed last week. This one has this neon orange paint on it. This one was not as successful, so it has a little bit of a glow. So what I did with this is I actually tried to make my own fluorescent paint. And that's a multi-step process. So first I took this highlighter, and look, it's got the nice glow there. And I took out the bottom. And once you take out the bottom, you can take out the middle part, and it looks a little bit like this. This one's orange, so it's different, right? This one had a yellow thingy that looked almost exactly like this in the middle. And if you cut that open, you get this nice fluff, right? And this fluff is soaked with dye, and you can put this in water, and if you do, you'll end up with something that looks a lot like this. Now, I didn't actually use this to make the paint though. What I did is I let it dry a little bit, and then I put salt in it, and you get cool crystals. And I mixed the crystals with white paint. So this was it was a fun project to do. But it didn't actually work out that well. When you put the crystals in the white paint, they don't actually glow very well. Not sure why that is, but this is still fun to look at. So to get this nice liquid, what I did is I took the fluff from the highlighter and I soaked it in water. So it's water and the highlighter fluff and a little bit of isopropyl alcohol. Now I wouldn't recommend using isopropyl alcohol for two reasons. The first is that it's kind of icky, it has nasty fumes, and it's irritating, and it's just not something you really want to mess with. The only reason I added it is because I wanted to make sure that it stayed fresh, like I didn't get any germs growing in it, but that's not going to be a problem if you just make this on the day that you make the glow water on the day that you want to use it. The second reason is that we're going to be using an experiment in a little bit. We're going to be using citric acid, and citric acid is insoluble in isopropyl alcohol, so it can affect the results of the experiment if you use it compared to just using water. But so we have this stuff, and it's fun. You can put it on paper, and it works pretty well as like a stain or an ink, but it doesn't work as well as just the highlighter itself, because the highlighter is concentrated, right? And so it shows up a little bit better. This one's not as great of an example because the orange in general doesn't tend to be as fluorescent as the yellow does. So I have some cool artwork that I made here. They're not super exciting, but what they are is they're kind of invisible, right? You have to hold them up to the black light to see them. So this one's a ghost. And I have another ghost and a skull over here. Those are visible under the regular light, or under non-black light. And then I have a jack-o'-lantern on this guy, on this green piece of paper. Shows that really well. Black paper doesn't work as well. I don't even know if you can see that. But I have the orange highlighter and the yellow highlighter. These barely show up at all under regular light, daylight, but they also barely show up as well. So it doesn't work as well. And of course, besides highlighters, you have cool paints like this that you can get cool tissue box monsters like this. All right. So that's the art that I did for this. Oh, one other thing. We have these guys. They're I don't know where you get these. I assume you can get them at a craft store or maybe a supermarket like Walmart or someplace like that. But they're glow in the dark gems or beads that you can use to make mosaics. But so now onto the experiment. So I actually got interested in what type of dye was inside of these highlighters, and it turns out that there are two different dyes that are used in them primarily, and I wanted to see whether the two different markers that I had the same dye in it. So these two are labeled Sharpie because I got them out of this Sharpie highlighter. Unfortunately, I threw away the case that I got this dye from, so I don't know what it is, and I put little question marks on it. So it turns out that these dyes, they're really sensitive to changes in the pH level, right? So if you add an acid like vinegar or citric acid, that's what we're using today, but vinegar will work just as well if you don't have citric acid. You can also use lemon juice because the main chemical in lemon juice is citric acid, right? It's named after citrus fruits. Or we can add a base. In this case, we're using baking soda. So these are relatively mild acids and bases. They're only going to change the pH a little bit, and they're also not going to irritate your skin like might happen if you used really strong chemicals, right? So we are going to add a little bit of these into this. So first, we're going to get a little bit of citric acid into this guy. That was about 4 drops. A bit more. That was a lot more than 4 drops. And look, it's clear. It has a very, very slight yellow tint to it, but not much at all. And this, the results are, you also see these under regular light. And we're going to add a squirt to the Sharpie. So that one reacted, it seems like it reacted a little bit better. So this one, we added about the same amount. This one has a very slight glow to it. This one has an even fainter glow or even no glow at all. So that's something to keep in mind. That was with citric acid, so that lowers the pH. It's more acidic. And now we're going to add baking soda. And just see, we're going to add a dropper in here. Well, it looks about the same. And this one looks about the same as well. Although you don't know how visible this is, but this one, the mystery one, isn't as bright as the Sharpie one that we added the baking soda water to. So they do act a little bit different. So well, I think that they're different dyes, but I could be wrong. But I will note that they actually look a little bit different in daylight as well. This one has a little bit more of a yellowish tint, and this one had a little bit more of a greenish tint. But the coolest part is this. We're gonna add baking soda water to this one. We're gonna have to add a lot because it takes more baking soda. And look, it started glowing again. So we added 3 droppers to that one. Let's see if we can make this one glow again too. So this one, yeah, again, we see a big difference in the glowing. This one glows a lot more than this one does, even though we added the same amount of baking soda water each. And then kind of related is, I don't know how well this is going to show up. So I reduced the dye in one of the highlighters in the Sharpie until there's barely any water in it at all. So I don't know how well this is going to work. There we go. So this dye actually, it tends to absorb water out of the air. It's hygroscopic, right? So that just means it tends to absorb water out of the air. But when it does, it has different qualities, right? So this is a very faint glow. If you look at it from a certain angle, it's almost like a reddish brown color. But if we add water to it, we'll add baking soda water, because we know that that'll make it glow and the other water won't. And it gets a different color quality. So right, it was very yellow before, and now it's a much more green color. So that's just something cool, that the highlighter dyes, they actually vary in color based on how much water the dye is dissolved in. If there's very little water, it's very yellow. If there's a lot of water, it's green, until the point where there's too much, and then you don't really get a good glow anymore. So that was our experiment for you guys. I hope you had fun. If you don't want to go to all the steps that I went through to do this, a very simple experiment would just be to get one highlighter to write and take the fluff out of it, and then just do that acid-base test with the baking soda and the citric acid, rather than using different types of highlighters or more than one. So as for why I'm changing the pH level, the acidity or basic level of the dye makes it change colors. When you add an acid to a solution, it increases the number of hydrogen atoms that are floating around, and these hydrogen atoms bond with the dye molecules, and they change the structure in such a way that it's a lot harder for the molecules to emit photons, right? So they can't emit photons, they can't glow. But of course, when we add a base, the hydrogen atoms that got stuck on the dye get stuck on the base instead, and it starts glowing again. Yeah, so I hope you guys had fun watching this, and I'll see you next time.